Okay, let's take a look at problem 3a. Okay, so the circuit in problem 3a is given here, and what we need to find out is the gain of the circuit. So to find out the gain of the circuit, we'll find out the relationship between V in and V out. Okay, so let's start the problem by just assuming that this amplifier is in active mode. You know that if a transistor has to work in the uh, work as an amplifier, it has to be in the active mode, right? So we'll assume that the transistor is in active mode. So let's write that. So assume BJT is in active mode. Okay. Now in active mode, so if what is the potential here? VE is 0 volts, right? Because it's connected to the ground. Okay. Now what is the voltage at this point then? VB. Now, because this is an active mode, you know that the base emitter junction voltage is 0.7, so VB will be 0.7 volts. Okay. Now, if we know that VB is 0.7 volts, we should be able to calculate IB. And what is IB going to be equal to? IB is going to be equal to V in minus 0.7 divided by RB, right? Now, if we have IB, we should be able to calculate IC. And what is IC going to be? IC is going to be beta times IB, right? Now, if we have IC, we should be able to calculate V out, which is simply VCC minus IC times RC. So which is equal to VCC minus, now let's replace IC. IC is beta times IB. IB is V in minus 0.7 divided by RB times RC. And so this turns out to be, let's see, V in plus 0.7 RC divided by RB minus beta V in times RC over RB, right? And so you can see that the signal here, the output here, is made up of a DC component, which is this signal, and maybe the DC component which is in Vin as well. Vin can be a DC plus a AC signal, right? So Vin can be a addition of the bias voltage and the signal actually. Uh, so if you look at the gain of the amplifier, it's simply going to be beta RC divided by RB, right? So gain is going to be simply minus beta RC over RB, because that's what is going to multiply the AC component of Vn. Is that okay?